This is problem 20 in section 11.3 found on page 675. It says that Mary Robinson wins $2,500 in a singing contest and invests the money in a 4-year CD that pays 3% interest compounded monthly. How much money will Mary receive when she redeems the CD at the end of the 4 years? The key word in this problem that tells you which formula to use is the word compounded. As soon as you see the word compounded, you know that you have to use the compound interest formula. And this is the compound interest formula. So to answer problem 20, all you've got to do is plug the numbers in the right spot. So A is the future amount. P stands for principal, just like it did in simple interest, so that's the $2,500 figure. 1 plus R is the interest rate, 3%. N is the number of compounding periods per year. So since this is being compounded monthly, there are 12 months in a year, so the compounding will happen 12 times a year. So that shows up here as well as in the exponent. And in the exponent, it gets multiplied by time, which is also in years, so 4. So if we can plug this in the calculator properly, we will get the right answer. So using our calculator here, 2,500 parentheses 1 plus 3%, 0.03 divided by 12, close the parentheses, use the caret to raise to the power. You're going to want to open another set of parentheses for the exponent, 12 times 4, and close your parentheses. Finally, hit enter, and we get 28, 18, 32. 28, 18, 32. And that's the answer to problem 20. Okay, this is problem 30 on page 676. States that after Karen Estes began her job as a waitress, she invested in a money market account, paying 5.6% interest compounded daily. What was the effective annual yield of this account? So effective annual yield is the same thing as annual percentage yield, which is often abbreviated APY. And what it is the simple interest rate that would yield the same rate of return as a stated compound interest rate. So how much would I have to earn in simple interest in order to earn the same amount as a compound interest rate? That's what we're discussing here. And to calculate APY, you will always use our compound interest formula. A equals P times 1 plus R over N to the NT power. And the values for P and T, every time you calculate this, will always be 1. We'll use $1 for 1 year and see what happens. So in problem 30, $1, notice they don't even give you a dollar amount. 1 plus interest rate was 5.6%. It was compounded daily, so N is 360 under the banker's rule. N is also 360 there, and the time is going to be 1. Again, notice they didn't even give you a time. You have to know the principal should be 1 and the time should be 1. So, putting all this in our calculator, we get 1 times 1 plus 0.056, changing the percentage to a decimal, divided by 360. Close the parentheses, caret, raised to the 360 times 1. And I realize I'm oversimplifying some things. You don't have to put times 1 because times 1 is still itself, so you could skip that. Equals, and I'm going to write down all these decimal places. 1.057593078. So what we just calculated here, this is not the APY. What we found out is how much money would be in your account if you invested $1 at 1 year under the conditions stated in the problem, 5.6% compounded daily. So if you wanted to know how much interest you actually earned, you could subtract 1 from the amount in the account, which is real easy to do. Drop the 1 at the front and you get 0.057593078. So you would have earned this much money on $1 for 1 year. Now, if you want to know what percentage you earned, you can say what percent is this of $1, and solving that problem just results to moving the decimal place 2 places. So 5.7, it's common to round APY to 2 decimal places, so 5.76% is the effective annual yield on this account, or the APY on this account. Okay, problem 38 on page 677 reads that after seeing its neighboring village obtain a new water tower, the City Board of East Dubuque begins planning to replace its water towers. The board estimates it will need $1.75 million to build the new water tower in 20 years. At this time, the City Board plans to assess its 2,753 homeowners with a one-time flat fee surcharge and then invest the money received in a CD paying 9% compounded daily for 20 years. Part A, how much money will the board need to raise at this time to meet the city's water tower needs at the end of the 20 years? Now again, they're asking for how much do you need now. So that means in the present. So this is a present value problem. And the formula for present value is P equals A over 1 plus R over N to the NT. It's very similar to the compound interest formula. In fact, it is the same formula. It's just switched around using algebra to solve for P instead of A. You'll notice I wrote that A equals this amount, not P, because this was a future amount, not what they currently have. We want to know what they currently need in order to have that amount. So if I take that formula and plug all the numbers in the right place, I'm going to have 1.75 million in the numerator, 1 plus 9% over 360 raised to the 360 times 20 power. And let's put all that in our calculator now. $1,750,000 divided by parentheses 1 plus 9%, 0.09, divided by 360. Close your parentheses, caret, open parentheses, 360 times 20, close parentheses, enter. And this is money, so I'm going to round this to 2 decimal places. So we get a value of $289,338.14. And that is the answer to part A. That's what they need today in order to have $1.75 million in 20 years. Part B says, before applying the surcharge, the City Board receives a federal grant of $100,000 toward the water tower investment. Taking this grant into account, how much should the surcharge be on each homeowner? Okay, so they need $289,000 roughly today. They're going to get a federal grant of $100,000, so we can subtract that $100,000 out. So they really only need to raise $189,338.14. We know how many homeowners there are. So if we take the $189,338.14 and divide it evenly among the homeowners, we get $68.78, which is how much they would need to assess in charges to every single homeowner in order to have the amount of money necessary in 20 years in order to build the new water tower. Now, politically speaking, this is the kind of things that can get commissioners fired because nobody wants to see a $69 one-time fee on their water bill. However, if the commissioners are good enough in their PR, they can explain that this is the most economical way to do this. What if they weren't forward-thinking and instead waited 20 years, at which point they need the $1.75 million? See what happens then. If instead of investing today, they waited, okay, we need $1,750,000. Let's say they still get a grant for $100,000, so we can subtract off the $100,000. So they only need $1,650,000. Let's say the city's even grown. So instead of 2,753 homeowners, there are now maybe, I don't know, 3,200 homeowners. If they waited till that point and said, okay, now let's build a water tower, they'd have to split the $1.65 million over 3,200 people. And so each homeowner would be charged a fee of $515.63, which I know the commissioners would get voted out of office if they waited to do that. So it makes a whole lot more sense to actually assess the fee today, because then the homeowners have such a smaller burden to bear of the total cost if they use the power of time and investing in order to earn the money. So just interesting food for thought.